All right, scientists, in this video, I want to help you understand how mass will affect the flight of your rocket. We didn't get a chance last class to talk about how this design feature affects your rocket, and now we can. So, understanding this takes us back to the second law, which very simply put says if you increase the mass of an object or if you apply the same force to objects of different mass, if you have more mass, you'll get less acceleration. Now, at launch, this has one effect on your rocket. When it takes off, the applied force from the compressed air pushes on your rocket and accelerates it upward. If your rocket has a greater mass, that acceleration, with the understanding that the force is the same, is going to be less. Now, that's not good, right? Because we want the rocket to accelerate as much as possible to get going as fast as it can, because that's going to give it more energy and take it higher up into the air. Okay, so the increasing the mass on the rocket in one way is negative, right? Because it's going to decrease the acceleration at launch. However, that is not the only time when your rocket is accelerating. Okay, as it's flying, it's feeling air resistance pushing against it. That air resistance is accelerating the rocket as well. That's another unbalanced force that's causing the rocket to accelerate. But in this case, the rocket is slowing down. So the second law still applies. With a greater mass, you get less acceleration. However, in this case, the decrease in acceleration means your rocket is slowing down at a lesser rate. In other words, it's slowing down slower. Okay. It's harder for the air resistance to stop or change the motion of your rocket if it has more mass. So, where does that leave us? Okay. Um, it leaves us here. Increasing the mass of your rocket will decrease the acceleration at launch, which isn't great. Okay, the rocket's going to be harder to speed up, but increasing the mass will also decrease the acceleration during flight, and this acceleration is the rocket slowing down. So the rocket will be harder to slow down. Okay, so what you're looking for is a balance. Not too much mass, not too little mass. Just like Goldilocks and the Porgs, not too hot, not too cold. You got to find the right balance between not so much mass the rocket won't take off, but not so little mass that the air just bats it down. Okay? I hope this helps. And if you think about the rockets that did well in our test launches of the prototypes, you'll notice that there was a range of masses in those successful rockets. All right, I hope this helps. Thanks.